Yes, class. Am I audible? Fahad, Priyadarshini, Rifat, and Wafia.
Yes, ma'am.
Okay. So I think all the students who had to join have joined right now. Others, as they'll come, let's start with it. I have waited for a long time. It's already almost 10 minutes past the class. See, we'll start with this lesson, electromagnetic waves. Now, electromagnetic waves, the term only you can derive. Electro means electric field. Magnetic is from the term magnetic field. So this is the last chapter of your first book, and this is the last chapter that deals with electromagnetism. After this, from the next week, we'll start with ray optics. So that will be entirely different chapter. Fine. So this summarizes and uses all your concepts that you've studied from electrostatics, right from the very first chapter that we have discussed till the last chapter that we have discussed, that is alternating current. So all these phenomena will get utilized, all the laws that we have studied, that will be reverted back. And then finally, the combination of these types of waves. So it was seen that when a time varying electric field was there. Time varying electric field means what? Electric field that varies in accordance with time. If time changes, electric field will also change. That produced a magnetic field. And also through some certain experiments, it was concluded that a time varying magnetic field could produce electric field. Means if a magnetic field is present, which is depending upon time, it will produce electric field, and electric field will produce magnetic field. So it means a wave that exists in both electric field plus magnetic field is known as an EM wave. Electromagnetic wave. Fine. So electric field plus magnetic field gives electromagnetic waves. That is what we are going to study. Certain waves are there which have all the components of electric field as well as magnetic field lying within them. So that's what we are going to study. How to remember first point very clearly. Electric field and magnetic field, both these fields, they are perpendicular to each other. Priyadarshini, were you having your exams right now? I think you were absent. Okay.
I'm having it.
So they are still going on?
Yeah, I have it till next Wednesday.
Okay. You have it till next Wednesday. Okay. One more thing, class. Next Thursday, you have the test of alternating current, as I have not Thursday, Tuesday, as I've already informed you all. So I think Priya, you were not there in the classes. Tuesday, will you have your exam on Wednesday, no? So I think Tuesday will be difficult for you. So next Wednesday, your exams will be over. All right, class. Now see. If these are the three axes, y-axis, z-axis, and x-axis. Physics exam is over, Priyadarshini?
No, ma'am, it's on Saturday. Day after tomorrow.
Okay, it's on Saturday. And what's the syllabus?
The first 5 chapters till
magnetism and matter. Okay.
I've got the recordings from that.
You have taken the recordings? Okay.
Yeah.
Good. If you have any doubts, you can text me on WhatsApp. I hope you have my number from the group you can take. All right.
Okay.
Fine, class. So see, electromagnetic wave, electric field is in one axis. Let's say here I have drawn the electric field in which axis? I have drawn this along the x-axis. So magnetic field will be perpendicular to this. So magnetic field will be where? Magnetic field, let's say this is lying along z-axis. This is magnetic field. So electric field was along this. Electric field was along y-axis, as you can see. This is the value from y-axis. Magnetic field is from the x-axis. But what is the quantity that is along x-axis then? If along y-axis you have electric field, if along z-axis you have magnetic field, then what will you have along x-axis? The third thing that is perpendicular to both the magnetic field and electric field is direction of propagation. So the wave keeps on moving in one direction, whereas the electric field and magnetic field move perpendicular to the direction of propagation, as well as they are perpendicular to each other. If electric field is along z-axis, magnetic field can be either along x-axis or y-axis. Direction of propagation will be along one of it. Three axes are there. All the three quantities take up one axis, and we all know all these three axes are perpendicular to each other. So electric field perpendicular to magnetic field perpendicular to direction of propagation. Fine. Now, how to write the equations, that is very important. These equations, you have done it in your 11th class. E is equal to E naught sine kx plus minus omega t. Easy and small, very easy and small. If time permits, we can easily complete this chapter in today's class only, because one topic, that is electromagnetic, this chapter is divided into three parts. First part is this, the introductory part, which involves the waves. Then second part, this involves the displacement current, and third part is electromagnetic spectrum. So electromagnetic spectrum, I'll tell you, but ultimately you have to do the electromagnetic spectrum on your own by yourself, because that is completely rote learning. So that you will do. Regarding displacement current, this has been recently added in your syllabus. Till last year, this was deleted, displacement current. So displacement current, we will see it at the end once we complete this. If we have time, then we'll complete displacement current in today's class only. Otherwise, displacement current was deleted last year. Until last year, it was deleted. I think for three to 4 years, it was deleted. From this year, it has recently been added. In brief, not in detail as it was included earlier. It is included briefly only. So we'll see it in brief only, but you have this topic. So these three parts are there. So one part you all have to do, two parts we'll do. If time is there, we'll try to complete it. Otherwise, on Tuesday, definitely this will get completed. So E is equal, and yes, class, please do revise this lesson, because the weightage is very less, but question definitely comes from this. So at least one question is fixed from this lesson. So if you know, if you're aware, electromagnetic waves is very short, especially electromagnetic spectrum. If you do it, maximum questions are solved. Even not for your class 12, for the entrances as well, for after the entrances that have that are present after class 12, for those entrances also, questions will be very less from EM waves, but question will be there. So this is a very short chapter from where the question will come, and such small topics are there that you all can also easily predict the question. Just have a look on previous year paper, you will be able to see this. I'll also take a test of EM waves, but first let us have the test of alternating current on Tuesday. I have already informed that in the last class on Tuesday. So 1 week you already have, this weekend you have, we'll have a test on AC. See, how do we write the equation? E is what? E is the electric field. The way I naught represented peak value of current in case of AC, the way V naught or E naught represented the peak value of voltage. Similarly here also, this E naught depicts the amplitude of electric field. Amplitude of electric field, you can say, or you can say the maximum value. Maximum amplitude of electric field or maximum value. Sine, you all know sine theta. This is just a generalized standard statement. You don't need to derive this. Just directly use this equation. Directly use this equation. K is new. K is angular wave. K is basically, this connects your wavelength to this equation. How? What is one wavelength? If a wave transverses, a wave has flown. This is one wave. Now another wave will produce. Now another wave will be produced. This way the motion of this wave will go. So from here, this point to this point is a half wave, and one crest plus one trough. This is crest, this is trough. So crest plus trough gives you one wave, and this entire length of a single wave is known as wavelength. So K connects your wave to the wavelength. So K is equal to 2 pi by lambda. So sometimes lambda will be asked in the question, but K will be provided to you like 0.5x. So we all know 0.5x means Kx is there. So K will be 0.5. How to calculate wavelength? Using this. Like this you can calculate. Then you have what? You have x. X is what? See, x is the axis. This represents simply the axis where the motion occurs. Simply the axis. If it was y-axis, direction of propagation axis. If it was along the y-axis, it would have been y. Along x, this is x. Now, plus minus sign is important. If it is written plus, it means direction is along negative x-axis. Negative axis, whatever is the axis. And if it is minus, this is along positive axis. What is along means direction of propagation. Oppositely, it will be written class. Do not get confused. If the equation is, let's say, 0.5 minus 3t, 0.5x minus 3t. So minus does not depict that it is along the negative axis, whereas the minus depicts that it is along the positive x-axis. If it is minus in the equation, opposite is the axis direction. See, axis can be predicted using kx. Kx will give you the axis, but whether it's negative or positive, you have both the axis. For y also you have positive, you have negative, z also, x also. So that is decided by this negative sign. T is fixed. This is the time. Omega is angular frequency. And angular frequency, we all know this is 2 pi divided by t. T is the time period, and this is not the time period. This is a time instant, particular instant. What did I tell you? Time varying electric field is there. It means as you change the value of time, electric field's value will also be changed. Also, I had told you that there is time varying magnetic field as well. So for time varying magnetic field also, you can write B is equal to B naught sine kx plus minus omega t, where all the variables are same. Except for this is the magnetic field, whereas V naught is the amplitude of magnetic field. Now, electromagnetic waves definition, which I have already told you. See, what is this? Electromagnetic wave is a wave radiated by an accelerated charge. The propagation of wave, from where the wave begins its motion, this is because of acceleration of charge. Wave is comprised of the particles. So each of the particle begins its acceleration. So as the waves accelerate, it propagates through space as coupled electric field and magnetic field. It means a charge gets accelerated in the presence of electric field as well as magnetic field, which are perpendicular to each other and perpendicular to the direction of propagation. This is the definition of EM wave, which we have discussed in the beginning of the class. C class. Before we go on to the properties, one part that I have already discussed when Fahad was asking, electromagnetic spectrum part, you have to do it on your own because you have to learn all those things, all the properties. But C class, from the electromagnetic spectrum, you will be having, this is also very important, questions from electromagnetic spectrum come a lot. Here, what all you have to remember. The entire spectrum. These are gamma rays. I'll discuss it. Let me discuss it right now so that you will have an idea. And class, one more thing. Everything, maximum notes are written in the class only. Class, when you write down at your notebook, all the notes get ready. Maximum things are written in the class only. From this part, electromagnetic spectrum, as I've told you, I'll share the table with you. I have the table so that you can do it from the table also. But I'll suggest you to do it from NCERT. In NCERT, this is given clearly. The heading is also given, uses and the wavelength, frequency, everything is mentioned in NCERT. So if you can prefer and refer to NCERT and can make your notes, that will be very good for all of you for this lesson, as this is a very scoring lesson and you can easily, though I'll share the table with you. I have the material so that you can easily, otherwise from where will you refer? I'll share it with you. Whatever I had to write it in the class, I'll share the table with you. You will remember it, you will learn it, but ultimately questions will be from NCERT. So it's better if you have a glance through the NCERT. Things are there from NCERT, it can have one or two things extra, but I will suggest you to stick to NCERT. So gamma rays are there. Then you have X-rays. So gamma rays are what? These are usually used in the treatment of cancers. X-rays are also used in medical diagnosis to see the images of the bones and the soft tissues. Then you have ultraviolet, UVR, which we say UVR radiation. This also has so many uses in medical sciences. Also, it has uses. It is used in healing and inflammation processes. Then this is visible rays. Here, when the electrons accelerate and come back to this position, come back to the visible rays, then they lie in this spectrum, and these are the rays which then strike our eyes. They are able to penetrate through the cornea, and on the retina, the image, an inverted and real image is formed, and we are able to see it. Otherwise, if visible rays, the spectrum is deleted from the whole entire electromagnetic spectrum, then we'll not be able to see the objects that are there. So if objects accelerated charge gets back and strikes the visible ray spectrum, then we are able to see images. So this is the visible rays. This comprises the entire range which is suited for human eyes. Then you have infrared. Infrared is completely based on the phenomena of radiation. Radiation you must have studied: convection, convention, and radiation. So infrared is based on radiation only. This is used to heat. The heat of infrared is used for detection of many things, as well as this is used in case of fractures and healing processes also. Infrared lamps are there. Infrared lamps and ultraviolet lamps are very similar to each other. The difference that arises with the bulb of infrared lamps are red colored. So that's how infrared lamps are distinguished. Otherwise, ultraviolet lamps are also two types: luminous and non-luminous are there. No need to go into the details, just remember the major points of it. Then you have microwaves. Microwaves are used in the radar communication and the microwave ovens as well. And last is the radio waves. Now, what you have to remember: their frequency, their wavelength, their uses. Three things you have to remember: wavelength, frequency, and uses. These three things, so you have to remember. In NCERT, production is also there, so it's better if you do the production of waves also. More than this, what you have to remember: identification. Uses will be given to you, like this ray is used to obtain images of the bones. So which ray is this? You have to first identify, yes, that will be X-ray. Then accordingly, and all those rays you will identify and you have to arrange it. Arrange it in what manner? See, all these rays have their frequency increasing in this direction. Frequency increases in this direction means gamma rays have the highest frequency, then X-ray, then UV, then violet, then infrared, then micro, and radio waves have the least frequency. Whereas the order of wavelength goes in this way. Wavelength is the highest for R. So this has what? This has highest value of wavelength and lowest frequency. This has lowest frequency and highest, opposite. This has lowest wavelength and highest frequency. So this you have to remember. Any of these waves can be given to you and the order can be asked. Microwave, for example, microwave, X-ray and ultraviolet have given. And it is asking, the question is asking you to arrange it in the increasing order of wavelength. So firstly, you will write microwave, then you will write violet, visible, and then you will write ultraviolet. Like this. This order should not change. This is the set order of all these. And try to learn this in this only, using this synonym. G, X, U, V, I, M, R. Gamma rays, X-rays, ultraviolet, visible, infrared, and microwaves and radio waves. I'll share the table with you on WhatsApp also, because I think many of you have joined the group later on. Other students who were there already on the group, they must be having it, because in other batches I had shared it on the group. So that's why it's already there. Fine. So these things you have to remember. Right now, this, what is the meaning of each term, definition, as well as this figure. This figure is also important. And electromagnetic spectrum that you have to do when I'll take the test, I'll be mentioning the questions, those questions also. Okay, note this down. Time varying means that is dependent upon time. For example, E was written as what? E naught sine omega t was also there. Plus kx was there, but omega t was also there. So it means as you keep on changing the value of this time, value of electric field will also get changed. Similarly, B was equal to B naught sine omega t plus minus kx. Omega t was there. It means magnetic field depends upon time. So that's why time varying means this only. See this graph. This is not actually a graph. This is y-axis. This is x-axis. This is z-axis. Now, wave is propagating along x-axis. That is what has been drawn here, direction of propagation of wave. Fine. Electric field is along the y-axis. So since this is varying sinusoidally, remember in the electric field's formula, sine is also there. So since sine is there, sine graph, we have already studied in AC. So sine graph will be like this. And these arrows are depicting that every particle is here. All the particles are having different amplitudes. Fine, this is electric field. And magnetic field is perpendicular to both. So if y-axis is also filled, x-axis is also filled. Now, which is the last one that can be perpendicular? Z-axis. So this is the z-axis that I have drawn. So every particle is like this. Now understood? Or should I repeat it once more? K is just a constant term. This is just a constant that is present in the equation to connect the equation with lambda. This is angular wave. You write it in terms of, this is basically inversely proportional to wavelength. So the constant that comes is 2 pi. So k is equal to 2 pi by lambda. So this k basically connects your equation to the wavelength. How to connect this equation to the wavelength? Either you can write it as k in order to avoid this, or you can write it completely 2 pi by lambda. So many a times for writing it as completely by 2 pi by lambda, we try to put in k. Otherwise, it has no such meaning. Done till here. So this is the electromagnetic spectrum. I'll share the table with you also on WhatsApp. Do revise it from the table, and especially this order, which has the greater magnitude than what. Now properties of EM waves. Let's start with the properties of EM waves. Yes. So properties of electromagnetic waves. First property we have already discussed, that electric field, magnetic field will be perpendicular to each other, as well as they'll be perpendicular to the direction of propagation. For example, if direction of propagation is along x-axis, electric field can be along y-axis, and if electric field has occupied the y-axis, then magnetic field will be along z-axis. This point we have already discussed. One point, Lorentz force we had discussed, and magnetic Lorentz force. Magnetic force and magnetic Lorentz force we had discussed. Remember QVB. Electric force also we had discussed, that was QE. From here, QQ gets cancelled on both the sides. So magnetic electric field divided by magnetic field gives you speed. From this small derivation, we can conclude the fact that the ratio of electric field and magnetic field is equal to speed of light. This shows what? That electromagnetic waves travel with the speed of light. What's the speed of light? 3 into 10 to the power 8 meter per second, no? So this is the speed of light, that is 3 into 10 to the power 8 meter per second. This is exactly the speed of electromagnetic waves. This can be proved by this one-liner derivation. Second point is this. Third point is regarding the speed of electromagnetic wave in vacuum. C, formula is this. C is equal to 1 by under root mu naught epsilon naught. Mu naught is what? Permeability. Permeability we have seen in magnetics, and epsilon naught is permittivity. Permittivity we have seen in electrostatics. So C is equal to 1 by under root mu naught epsilon naught is what? C is equal to under root mu naught is permeability, epsilon naught is permittivity. Both govern the force with respect to the medium, but it depends upon which medium. Either it can be electric field, so it will be epsilon naught. If it's magnetic field, then it will be mu naught. Now, if you put in the values of this, mu naught is what? 4 pi 3.14 into 10 to the power minus 7. That's what we write the value of mu naught. 4 pi into 10 to the power minus 7. And epsilon naught, we already know this is 8.85 into 10 to the power minus 12. If you keep in all these values, you will exactly get 3 into 10 to the power 8 meter per second. So this is the speed of EM waves in vacuum. This you all know already, but to prove this, this formula can be asked in the exam. This formula can be asked in the exam. Fine. Now, EM waves in a medium. Suppose the medium is changed. So we have discussed this already, that epsilon will be equal to epsilon r and mu will be equal to mu naught into mu r. See, if epsilon r is the relative permeability and epsilon is the, epsilon r is the relative permittivity. Epsilon is permittivity of a medium and epsilon naught is permittivity of air. This we have already done a lot of time back when we were discussing electrostatics only. That time we had discussed this relation. Similarly, mu is also equal to mu naught mu r. This we had discussed when we were doing chapter number 5. Mu is equal to mu naught mu r. So if this is the case, keep it in the value. C is equal to, or not C. Now the speed will be different. This is another medium. This cannot be speed of light. This is some other speed. So speed will be what? 1 by under root. Instead of mu naught, you will write mu naught mu r. Instead of epsilon naught, it will be epsilon. Epsilon is what? Epsilon is epsilon naught epsilon r. What we have done, we have written 1 by mu epsilon. This is the new speed. If it is mu naught, if it is epsilon naught, that becomes the speed of light. Speed of light, we all know, that is 3 into 10 to the power 8 meter per second, as discussed right now. If it is some other medium, then this is the speeds formula. Now, keep in the values, just separate the values. If I separate these values, I am writing mu naught epsilon naught here, and I am writing under root mu r epsilon r over here. Why am I writing? To get one quantity. C class 1 by mu naught epsilon. Right now only we did it, that this was the formula of speed of light. So it means EM wave speed in any medium can be written as C by 1 under root mu r epsilon r, because this is already speed of light. So if you have a different medium, relative permeability, relative permittivity will be provided to you, and how to connect it with speed of light, that you can easily write down, right? So this is just, as I've told you, EM waves is just a revision of all the lessons that you have done in first book, and after this no more part you have from this portion. Optics is an entirely different, modern physics is different, semiconductors is different. So this is the last lesson that deals with all these electric fields and magnetic fields. Communication systems is not in your syllabus. Refractive index, we'll do it in optics. Two topics are here. I have written this, refractive index and optical phenomena. These 2 points we'll cover it in optics. For that time, just note it down. You can remember it in your notes, so that when you will do optics, you can relate it with the fact. Leave this concept, but just copy it. When you're copying it, do copy it down. Energy density. Energy density means energy per unit volume. So this energy is comprised by the electrical energy as well as the magnetical energy. Why magnetic and electrical? Because both the components are there. Electric field also exists as well as magnetic field exists. See, electrical energy that is present. Electrical energy is half E square epsilon naught. Whereas magnetic field, see, magnetic energy is half will be same. Instead of E square, here will be B square. Epsilon naught is getting multiplied. Permeability will get divided. Like this, remember the formula for magnetic energy as well as remember it for the electrical energy. This is the formula. So total energy density will be what? Electrical energy is this, magnetical energy is this. If you combine both the total energies, you will get this. So this is what type of energy. As I think in the last class, one student was there, no, Fahad, you were only there, who was asking regarding RMS value. So since nothing, whenever nothing is given, it means this is the RMS value. So total energy, we can write this as E RMS square epsilon naught plus half VRMS square by mu naught. So how to replace ERMS? ERMS is E naught divided by root 2. So BRMS will be what? It will be B naught divided by root 2. What will be square of ERMS? If you square this term, you will obtain E naught square by 2. If you square this BRMS whole square, you will obtain B naught by 2. Clear? I have just squared all these terms. Now, if you square all these terms and keep it in the formula to get the peak value, C, total energy, half is there. Instead of ERMS square, I can write it as E naught square by 2. This is ERMS square. What is left? Epsilon naught plus half BRMS square. I can write it as B naught by 2. This will be B naught square by 2. And what is there? 1 by mu naught in the denominator. Now combine this. See what's the final equation you're obtaining. Total energy will become what? Total energy will become 1 by 4 E naught square epsilon naught plus 1 by 4 B naught square by mu naught. This is the total energy that will be obtained. First, tell me, any doubts till these points? This is the last point, I think. Momentum is the last point. No, intensity and momentum. Yes, these are just the last points. But I'll proceed towards momentum and intensity once you have understood this. I'm repeating the points very briefly. Whichever point you're not able to understand, just stop me right in place. Except for fifth and sixth, refractive index and optics, we have not started now. See, all these three are perpendicular to each other. Second point, EM waves travels with speed of light. Third point, this is the formula for speed of EM wave in vacuum, which ultimately will give you 3 into 10 to the power 8 meter per second, only because you know the final answer. But if you have to calculate it in a separate medium apart from air, then what you can do, you can use these two relations which you have studied in electrostatics and magnetostatics. So instead of epsilon naught, mu naught, for a different medium, epsilon and mu will be used. So this can be written as mu naught mu r, epsilon epsilon r, where you derive C. So final new formula that you will get is V is equal to C by under root mu r into epsilon r. The refractive index formula is under root mu r into epsilon r, and all optical phenomena are due to electric field, no role of magnetic field. Energy density is energy per unit volume. Formulas for energy, electrical energy is this, magnetic energy is this. You have to remember both these formulas. This formula also you have to remember, and this formula also you have to remember. So total energy will be the sum of these energies. If you want to write it in terms of peak value, you will get the same equation with 4 in the denominator. Tell me, is this clear? Then I'll proceed to momentum. Is it clear?
Yes, ma'am.
Okay. Good. If you have any queries, let me know. Momentum. Momentum and intensity, these are not difficult. Okay, good. Momentum is basically in EM waves, not in your normal mechanics. From mechanics only this has been derived though, but derivation, don't go into the derivation, it's a lengthy derivation. This is energy. This is speed of light. So just remember the formula. Even questions, if are asked, you can simply use this formula and solve. So momentum is energy divided by the speed of light. Just remember this. And force is what? Force from your seconds, Newton's second law of motion. Newton's second law was dp over dt. So same thing. Force will be P divided by T. This is for absorbing surface. Means a ray of light, this is there, a rough surface is there. An electromagnetic wave has struck this surface with momentum P, time T. Understood? This is the first case. So F is equal to P divided by T, where T is what? T is time. Now if I have a reflecting surface, if I have a reflecting surface, light will move away because reflection has occurred. Let's say this is P2. This is the second case. And this is the first one. Now see what will be total momentum. If I take 1 as positive, let's say this is P1, whose value is P only. This is P2, whose value is P. Now, if 1 is positive, one direction is positive, then obviously other direction I have to take it as negative according to the sign convention. Momentum, I cannot write if one momentum is pointing towards downwards, other is pointing upwards, and I want to write out what's the net momentum. So how will I write? It's like relative velocity. In relative velocity, what happened? See, if a car is moving, let's say, suppose this is moving with 5 meters per second, and V1, and this is moving with 3 meters per second. So let's say we take this direction as, this is what, right hand side as positive. So both of these become positive. So net is V1 minus V2 will give you 5 minus 3, that is 2 meters per second. If let's say this is pointing towards right, but V2 is pointing towards left, 3 meters per second, Now what will you do? Will you still write it as 5 minus 3? No. If choose one direction as positive, other as negative. Let's say right is still positive, so I have to choose left as negative. Now it will be what? 5 minus, instead of 3, it will become minus 3, which will be 5 plus 3, which is 8 meter per second. Do you see the difference? 2 was here and 8 is over here. So same case we have it here. This is getting reflected. So let's say this is positive, 1 is negative, this is plus P, this is minus P. So net momentum will be what? Net momentum will be simply P1 minus P2. So you will write P1 as P minus P2 is what? Minus P, that becomes 2P. So what I was trying to tell you is force for a reflecting surface becomes 2P by T. It becomes twice. Whereas force for a normal absorbing surface where in electromagnetic waves rays strike, that is Fp by T. Is this clear? Why it's 2p by T? Basically, I was telling you the formula is 2p by T. And why it's 2p by T? That I've discussed. This is just because of sign conventions. Understood?
Yes, ma'am.
Yes, ma'am.
Okay. And last is intensity. Remember, intensity is formula only here, because questions from intensity though are there, but mainly questions are from dual nature, from your modern physics as well. But intensity is included in this lesson, so do not ignore that. That's why I've written the formula already here. Intensity is power per unit area per unit time, and also you have to remember the SI unit also. See, power is what? Power is what? Area is meter square and time is seconds. So you can directly write it as what? Per meter square per seconds. This is the SI unit that you have to remember. So from intensity, direct questions will come. From this chapter, direct questions will only come. Indirect questions are not asked. Maximum it can ask you this. This is also, I have not seen in any of the questions where force and this 2p by T and p by T is used. But this is the maximum difficult part that can be asked. Apart from this, no part is left from which any question can be asked to all of you from this lesson at least. All right, note it down. Any point you do not understand, let me know.
Ma'am, can you scroll up?
E naught B naught means the amplitude. See, the way we had for the current, the way we had I naught as the maximum, E naught means the maximum value of electric field. What did we study? Electric field is time varying. So it means for different values of time, we'll be having different values of electric field as well as magnetic field. So the highest value among these will be E naught, and the highest values among the magnetic fields will be B naught. That is the peak value, you can say, amplitude you can say, or the highest value you can say. Okay, that question was left, Fahad. We didn't do that question on transformer. Okay. One question from transformers is also left. Thanks, Fahad. Just remind me once on Tuesday, because that question is important. One question that I had mentioned. We'll do that question. I totally forgot about that question. I thought we had completed the entire lesson. Just remind me once again, though I'll do that numerical as well as we'll complete this lesson. No need to write that example of relative velocity. That was just for understanding. Just text me done when you have written this 10th point, then you all can leave and we'll continue the question of transformers on Tuesday. We'll complete this displacement current which is left and we'll have the test.
Ma'am, we have to remember this formula 2p by t.
Yes, you have to remember this formula 2p by t. As I was mentioning that rarely this formula has been asked in the question, but this is a part of your syllabus, so that's why just have a look on it. Important topics are intensity and the total electric energy that we had, electric and magnetic energy, as well as one more thing, momentum.